Welcome back to The Explainer. Today we're putting on our digital hard hats and stepping right onto the ultimate construction site. We are going to explore the foundational blueprint for building a massive, highly efficient digital city in the cloud, specifically using the Google Cloud Platform. Whether you're just laying down the concrete for your very first virtual machine, or you're looking to automate an entire skyscraper using smart, serverless tech, understanding these architectural fundamentals is absolutely crucial. We're going to look directly at the materials, the tools, and the key decisions that make modern cloud computing possible. Here's our architectural blueprint for today. We'll start with cloud versus on-premises, then balance compute control against convenience. After that, we'll hit the 4 types of storage, lay down some networking and security basics, and finally wrap up with specialized serverless services. All right, part 1, cloud versus on-premises. Okay, let's dive into this massive architectural decision. There is a stark contrast between these two approaches. Think of on-premises as buying the land and building the physical servers yourself. You're owning the infrastructure and committing to it for, a solid 3 to 5 years. Now, that really only works well if your company has a crystal ball and can accurately predict server needs for a long time. Or maybe you just have a fixed IT budget. But if you get it wrong, you're stuck with really expensive hardware just gathering dust. Cloud computing, on the other hand, is a totally different paradigm. You're renting resources short-term with the pay-as-you-go model. The real magic here is elastic resource allocation. Public cloud providers have massive pools of resources and they can instantly shift them around, letting you scale up or down on the fly. Plus, you get access to specialized services you'd probably struggle to build from scratch. Moving right along to Section 2, Compute, Control versus Convenience. Think of this next phase as a giant metaphorical slider on a mixing board, balancing 2 competing desires. How much do you want to control yourself versus how much you want to let the cloud provider handle? Step 1 is virtual machines. This is your maximum control. You're the hands-on mechanic here. You create the VM, you configure the file system, patch the OS, change the directory permissions. It's a lot of manual work. Slide over to Step 2, managed Kubernetes clusters. And the cloud provider takes on some of that heavy lifting. They handle the monitoring, the networking, and some of the security for your clusters, so you've got way less overhead. Finally, crank that slider all the way to Step 3, serverless, maximum convenience. You do absolutely zero server management. Your developers just run their code in containerized environments managed entirely by the cloud provider. Let's test that concept right now with a quick scenario. Imagine you're building the back end of a website and you need to process files. You want to stay all the way on the convenience end of the slider. You want serverless. Based on Google Cloud's offerings, which 2 products fit the bill perfectly? Think about it for a second. If you guessed Cloud Run and in-cloud functions, you hit the nail on the head. These 2 are the heavy hitters for serverless compute. A user who wants minimal setup would absolutely love these because you're only charged for the exact time they're running. No pain for idle servers just sitting around doing nothing. So here's a great rule of thumb to keep in your back pocket. Managed services and serverless options are good choices when you do not need control over the computing environment and will get more value from not having to manage compute resources. It really all comes down to where your team's value lies. If your team's superpower is writing amazing code and not patching Linux servers, well, serverless is for sure your best friend. All right, Section 3, the 4 types of storage. Let's shift our builder analogy from the engine room of compute to the actual warehouses where we store our digital materials. First up is object storage. I want you to picture a massive, endless, flat parking lot for your data. It's incredibly reliable and durable. Say you have an app where users upload huge image files to be analyzed later. This is exactly where you park them. But keep in mind, it's got more limited functionality than a traditional file system. You aren't going to run an operating system off this. You just use it to safely park big, discrete objects. Our second warehouse type is file storage. So if object storage is that flat parking lot, file storage is your traditional, highly organized office filing cabinet. It gives you that familiar hierarchical directory setup, it supports normal OS functions, and crucially, it provides network-accessible file systems that multiple servers can tap into at the exact same time. A great example of this in Google Cloud is Cloud File Store, which is based on the classic network file system or NFS tech. Third, we have block storage. Think of this as taking a raw, high-performance hard drive and plugging it physically straight into your setup. It uses persistent disks, your SSDs and HDDs. The big deal here is that it allows random access to specific parts of files. If you're spinning up a relational database or you need a drive attached to a VM for rapid, random transactions, block storage is absolutely the system you need to use. And here is a fun, specific piece of architectural trivia for you. While block sizes can technically vary, 4 kilobytes is a standard, fundamental unit size that pretty much all basic block storage systems utilize. Our fourth and final storage type is caches. Now, caches are an entirely different beast. They are in-memory data stores. I like to think of them as the sticky notes you slap on the edge of your monitor. They exist purely for speed, to minimize retrieval latency. Because they use memory instead of disks, they're lightning fast, way faster than SSDs or HDDs. But, and this is a massive but, they do not provide persistent storage. If the power cuts out, poof, that data is gone. They can also easily get out of sync with your main database. So a cache should literally never be considered your system of truth. Moving fast, Section 4, Networking and Security Basics. Okay, time to lay down the roads and borders for our digital city. The foundational boundary here is the Virtual Private Cloud, or VPC. Whenever you create resources in Google Cloud, they're always part of a VPC. It's your isolated plot of land. To connect your plot to other networks, or maybe back to your on-prem office, you're going to use network services, things like VPNs, interconnects, and various types of peering. And of course, within your own borders, you need security to establish very strict limits between your different internal subnetworks. Which brings us to another quick architect check. Let's say you've set up your VPC. Your company demands multiple internal subnetworks, maybe one for HR data and one for public web servers, and you have to strictly limit the traffic flowing between them. What specific network security control are you reaching for? So the crucial point is you need a firewall. Firewalls are absolutely essential for controlling the flow of traffic between your subnets. They act as the internal security checkpoints inside your digital city, making sure only the exact right traffic gets to the exact right places. And finally, Section 5, Specialized Serverless Cloud Services. When we reach the absolute peak of our Cloud Cities architecture, we find things like machine learning through AutoML, speech-to-text translation, and those super complex recommendation services. What's wild about these specialized services is that they are purely serverless. You don't pick VMs, you don't configure clusters, you literally don't even monitor the underlying infrastructure. They just provide a highly specific function via an API. You ask the API question, it hands you the answer. The cloud does all the heavy lifting. Let's hammer this concept home with one last scenario, just to see if you fully grasp the far end of our convenience slider. You're managing a huge retail op. You plan to use AutoModel to analyze tabular sales data and predict demand. At peak times, you need to analyze up to 2,500 products an hour. Huge load. As the architect, how many virtual machines should you allocate to make sure this system doesn't crash? The answer is 0. Absolutely 0. Because AutoModel is completely serverless. The cloud provider instantly scales the resources entirely in the background. You don't touch a single server, you just sit back and get the predictive results you asked for. We've covered a ton of ground today, from the heavy, rigid commitments of on-premise servers all the way to the magical, zero-maintenance world of specialized serverless tech. You've got the architectural blueprint for compute, storage, and networking. So I'll leave you with this final thought as you head out to build your own digital city. On your very next project, are you going to demand the total hands-on control of managing your own virtual machines? Or are you going to slide all the way over to convenience and let the cloud do the heavy lifting? Keep learning, keep building, and I will see you in the next explainer.